derived it, you saw where it came from, part B. It looks like that. Now, I wish it's one of those you could just look at and say, Professor, I see the answer. Can I, in this particular one, say quickly the answer must be 3? Can I just look at it and say the answer must be 3, Professor? Give me a good rationale why I cannot. Why can I not merely look at this one like we were looking at some of those before the break and said, oh my goodness, I see the answer immediately, Professor, without going through the routine. Why can I not do it here? Geez, where's my class? Why can I not do it here? Yes.
It's not a linear.
It's not linear. It's a quadratic. Now, if, I'm gonna go back to my problem though. If this had been this, and this were missing, now it's linear. Now you're guaranteed. If you do the routine, you're gonna get 3 for an answer. But mine was not like that. It was 3x squared. I think I had an x in the middle. Is true, guys? That's what it originally looked like. So I will tell you ahead of time, we have to do the difference question. We'll get a difference question done. But it's not going to be an easy, simple answer. Yes, go ahead.
It's minus x, not plus.
Was it minus?
Yeah.
Right here? Thanks. Okay. So I'm going to do it. I'm going to use this formula, called the difference quotient, which is slope. But it's not going to be an easy answer to observe here. Okay, guys, here it goes. First, please, when you see one of these on the quiz, exam tomorrow, I'll probably just give you one of these. Break it up and just do it in pieces. The first piece of the formula says express f of x plus h. That means go back to the given function, whatever it is, and replace all those x's with x plus h. I would be very patient. And x plus h. Move that up. Plus 4, be very careful. Block that off. Look at that, how lengthy. That's just this. That's just f of x plus h. Now am I finished with the formula? No, it says don't stop there, now subtract. And on the end it says now subtract this in the formula, which is the original function. So we'll just repeat what was given to me. This. Lock that off. I'm going to mark this out to show I've used it up. That's what that was. And still you're not finished. All this is over h. Okay, let's see by a quick show of hands, how many students have had a little calculus somewhere? Maybe you took a little calculus back in high school. Has anyone had any calculus? I see a few hands going up. Yeah, this is a major thing to be done in calculus. Now, if you guys accept this, I give you definitely points for this much. But you're not finished. You got to simplify it. Now to simplify it, guys, this will take a little effort. Bear with me. This right here, expanded out, is x squared plus 2xh plus h squared. X plus h times x plus h. Then the 3 out front says don't stop there. Now let's use the distributive property. Distribute the 3. And guys, if I distribute the 3 on that blue, I'm going to end up with 3x squared. Here we go. 6xh plus 3h squared. This is going to be a bit messy. Are we okay so far? I'm not finished yet. I've taken care of that. Now I'm down here, which says merely distribute that negative sign, subtraction sign on that. When I do that, you end up with negative x subtract h. That's done. Still got the plus 4 hanging on. That's done. That's right there. Down here, to go further, like a distributive property, change some signs. Negative 3x squared plus x subtract 4. Look at that mess. All this is over h. And then you try to clean it up further. When I say cleaned up further, let's see what's going to happen here. Some of these terms I think will cancel out. well, we cancel out the wrong ones. 3x squareds will cancel. X's will cancel. 4's will cancel out, they're gone. Guys, that leaves me at this point, let me copy it down. It leaves me at this point, these terms, everything else cancels. 6xh plus 3h squared minus h. Still over h. You guys agree? Now, see, one more item to do algebraically, and this will clean it up. What, does anyone see anything else that can be done here to simplify this a little further? All right, here's something. Factor out an h, they all contain an h in the numerator, so take that h out, be careful. You got 6x plus 3h, subtract 1, all over yet h. I got a common factor of h in my numerator. And now what will eventually happen now? I just have one more step. Will the h's cancel? These. Now, I wish, here's my answer. My answer is this. 6x plus 3h subtract 1. Are you kidding? That's the best you can do when they say find the difference quotient on that quadratic. If it had been linear, oh my goodness, my answer would be like a nice number like 4, 3, -2. Quadratic, a mess. Big mess. But that's the best we can do. So it's called a difference quotient. And for me, for a pre-calc instructor, all I'm going to do is just set you up for what that calc instructor is going to now pick up with when you finally take the course. They'll pick up this if I ask you to do a couple of these like I'm doing now, but then expand upon it and do a little bit more with it. Guys, any concerns here? It's messy. Really, really messy. Now, what's all this representing? What's the key word? What's all this representing for a difference quotient? Slope. It represents something about slope. And look at this. This is a quadratic. This is a parabola. You say, Professor, find the slope of a parabola? I find the slope of a straight line. I've never in my life seen find the slope of a parabola, right? But this represents slope on that parabola at a certain point. So we know what it means. But please, guys, understand before tomorrow, if you have one of these, practice tonight. Be at my 2 o'clock session tomorrow and ask questions. We're finished with this one. That's the difference quotient. Now, I'm not going to spend too much more time with the difference quotient, but I do want to take into consideration one more on that part 1 on the handout. Was there one with the fraction involved? Okay, what was that function listed as? Someone, f of x equals what?
2 over x plus 1.
2 over x plus 1? There we go. And they want you to find the difference quotient. This is the last one I'll do for right now. Now before I jump into it and do it, just like I did the last one, was there one more on that handout that maybe had a square root? And that one's frightening. I'm not going to do that today. No, that one's, it's frightening. Now, before I jump into the one you mentioned to me right here. One thing about when you try to simplify these, one thing you'll always find if you're simplifying it's going to correct it for you, is that h on that denominator will finally drop out somehow on all these. That was right here, I hope it does. Here we go, guys, we're trying to find this. All you have to do is be very patient. Just follow the formula. There's my formula. First, like I said before, let's do it in pieces. Here's the first piece. Merely find f of x plus h. Don't be patient. Go back to your function and replace x with x plus h. I'm going to use the blue here to show that. And I know it's looking strange already. x plus h in for the x plus one. That's what this means. Then subtract from that the original function. Now that's just merely recopy this. And don't stop there, all over h. Do we agree? I'll give you partial credit just to set it up for me. I'm happy when you set it up for me. Now though, if, and I gotta simplify this answer at this point, this eventually has to go. That's one nice thing about these difference questions. If you simplify it correctly, this h in my denominator is eventually going to go. Now, I can't make it go right now. I had some students get ambitious and say, Professor, just cancel here. They're gone. You can't do that. Not with that location of that h. Can't do that. Guys, does anyone have an idea? It's on the handout. Or maybe I had a student who may have tried this. Did anyone try this one? Really? Wow. Did you guys work it all the way through?
Yeah.
Okay. Now, watch me there. Don't let me make a mistake, John. Boy, you guys are good. Now, what would you suggest I do in an attempt to simplify it? Look at it. I'm staring at you. What are you going to do algebraically back in middle school? And I'll give you a hint. That teacher back in middle school, if he had this, subtract this, over maybe this. What? Right, there you go. You had to put those two together with a common denominator. That was in middle school. That's the same thing here. I need a common denominator. That common denominator may look strange for the problem we're working. Here it's merely 4. Now, can anyone tell me if I intend to combine those two with a common denominator, these two on top, with a common denominator, be very, very, very careful. Jonathan, you said you tried it. What did you combine them with? What common denominator did you use?
I ended up with, let's see. There was a lot, so let me see. The bottom was x plus h plus 1 and x plus 1 was on the bottom. So it's like x plus h plus 1 multiplied times x plus 1.
That's my common denominator.
That's kind of, it just kind of sucks.
That's going to take this, like I'm hearing what you're saying, this times this. Now guys, that's just for the top part. I'm trying to combine those two fractions like that middle school here, the common denominator is 4. Much easier back then. I'm using the same process though. I'm combining, and the best I can do is to multiply these two together and serve that as my common denominator. Okay? By the way, back here in middle school, you could have used 8 for your denominator. Usually ask you to use the least, which is 4 in this case. But you could have used 8, just 4 times 2. Now, Johnson?
Yes.
I also had another student since he got it. So just give me some input if you see me doing something wrong. Say, Professor, hold on. Okay. Now, if I want those to put together that strange common denominator, which is both these put together, I know that the first one's missing the x plus 1. I've got to put it in. This one of that common denominator is missing this mess. X plus h plus 1. Now, just bear with me. Now, do those two on the top there, the numerator, at least have the same denominator? So all I need to do is find out what's on top here of the fractions. Guys, here, really use a distributive property. You're going to end up with 2x plus 2, looks like. And I would, now I'm asking the guys who got this to work out, you could think less -2 distributed on that orange to see what's on the end. Is that sort of what you guys did?
Yeah.
So am I going to end up with -2x, -2h, minus 2?
Yes.
Whoa, what a mess. And all that's over that common denominator. I know we're going to cancel some terms here shortly. As if that wasn't enough to worry about, you still have all of this over what? That h is still there. That h is still there. have one of these on the test tomorrow. You're hoping it's not one like this, aren't you? In fact, some students may say, Professor, I'm hoping it's not even one that looks like this. And Professor, I just messed up here. I'm even hoping you don't have this. What are the answers for? That's when you're hoping to get it. Okay? Now, look, quite a mess here. Okay, guys, let's finish this up. To simplify this further, I've done so much work here. All my markers are right up here. Okay, let's do this. Guys, the 2x's cancel. Oh, I got better. 2's cancel. That leaves me what? Negative 2h? Still over this mess. Look at that mess in the blue. That's my common denominator for this fraction. All over h. I mean, you gotta be very careful on these. Now, if we're going further, if you reflect back to like you about to say in middle school, and look at this. If you had something like this staring at you back in middle school, and the teacher asked you there to simplify that, which somewhat looks like what I have. I have a fraction on top over h. Here, middle school, what's the answer?
1/6.
What is 1/2 all over 3 divided by 3? I'm scared. Yes.
1/2 times 1/3.
You can write this as 1/2. It's being divided by 3, and he's saying, Professor, that's the same as 1/2 times what? 1/3? That's middle school, right? Elementary. Now, 1/6, isn't it? Is that true? Is that just really taking this down here and multiply these two together? And I got 1/6 fairly quickly just doing that? Now, if that's true there in middle school, then we're back here. Can anyone tell me what mine, best you can, would look like on my problem? You saw what I did on the elementary school or middle school problem, and what would mine look like based on this? Anyone?
The same as we normally do, you just multiply by the reciprocal.
Okay, so you're saying, hang on now, Jonathan, you're saying this. You're saying the elementary school problem up there says negative 2h over this mess times this, oh boy, calculus, all over h, divided by h. That's what you're telling me to do. I think. You're saying all that, Professor, is being divided by h. Guys, by the way, does this and this say the same thing? And then that means, he's telling me, that this times this times what? The reciprocal? 1/h. Yes or no? Is that what we're doing up there?
Yes.
In the elementary school problem. Same thing? 1/h? Guys, could I, if I'm clever, could I write out this point, because I know this has got to eventually go in all my problems. Could that h now be gone? Even at this point? Is there a way to say valid? I mean, it's going to be valid that it's gone. Could I cancel these right here and not really worry about anything? Just want to cancel those? You think it's possible? I hope I can. If so, you're left with what? Negative 2 over x plus h plus 1 times x plus 1. Now, am I going to ask you to multiply this out, expand this out, multiply it together? No, you've done enough work. You're wiped out by the time you get to this point. So I'm happy to just get right there. And that's called the difference quotient for, where's my original function? Oh, it's way back here. That's the difference quotient for that function. Okay, and I will not do the square root.
Is that a long problem?
The square root?
Yes.
Oh, that's a long one.
That's okay.
Yeah, I'm not doing that today. There we go. Okay, so guys, tomorrow I'll try to keep it as basic as I can. I'll tell you ahead of time, it's not gonna be linear. I'm not gonna give you a linear function. But you know the answer without doing the work, right? We did one of those. More than likely, it's gonna be one of these. More than likely, it's gonna be a quadratic. I don't think I'll venture into this right now. I think I'll probably keep it as a quadratic, since you guys are just seeing it for the first time today. Okay? That's the difference quotient done. They said, Professor, how much more is there? Does this go on forever? It continues. It continues. Did you know people when they work, go to grad school, I keep on talking about grad school, and then they take math course after math course after math course, you probably think, does it ever end? No, I had some friends who stayed on afterwards. They stayed on afterwards. They worked on what they call postgraduate work. God knows, they may still be there. Who knows? They just kept on. They wouldn't leave campus. They would not leave campus. They just kept taking courses. I don't know whatever happened to them. Okay, guys. To close this down, and then I got just a little time here. Did a great job today, I think. I think we did a great job today. And I'll talk a little bit more about that exam coming up, but I got a beautiful exam for you. Here's the way it'll close, sort of close down here. I'll just call this part 2. Here we go. I'm ready for this. Put myself in the middle here. Oh, yeah. Oh, here we go. On that handout, are there some functions listed, other problems on the handout? Are there some functions listed on that handout that may have 3 parts to the function, 2 parts to the function? Is that true? And I have not touched those at all, have I? No, I have not touched those at all. Okay. I'm going to touch. Part 2. I'll start with this one. This one may be one of those listed. I'll talk after that. Guys, check your handout and see if there's one. In fact, I have the handout right in front of me. Oh, there he is. Here we go. This one has 2 pieces to it. It's x if this, negative x if this. You say, Professor, my goodness, this is the what? Is this our, let's see, 4th day together? Is it the 4th day? Are you kidding? This is the 4th day, and all of a sudden we're in the 5th chapter. Welcome to summer school. Jeez, 4th day. Yeah, if I want to graph this, it's given to me. This one has 2 pieces. You'll be shocked what the graph is. Some of my students may know. Let's go graph into. For this first example, that's why I have it on the handout. I want you to look at the restrictions here. F of x is equal to x. I can graph that. But the restriction is they want only this piece. So they call this piecewise function. Piecewise defined function. You guys, these will be given in pieces. I give you 2 pieces, and I'm going to look at one, I think there's another one on there for like 3 pieces, I think it is. Okay. Now, I would suggest, this is me, I would suggest, let's do a little tape on the side here. This is the first time me and Susie have seen this. And try to translate, and then we'll graph that first piece. That first piece says you can use for the x only numbers greater than or equal to 0. So we'll start with 0, my table. And then say greater than 0, let's try 1, try 2. You try many other numbers you wish. I think 3 is good enough. If I take 0 back and put it in right here, here's my function. If I replace x plus 0, that's 0 in the first piece. If I should take 1, which satisfies this inequality, 1 back to my function, which is x, replace x by 1, it's 1, not exciting. And 2 is going to give me merely 2. So there's a table that sort of shows you what's going on. You're allowed to use numbers greater than or equal to 0 in that function. When I jump down, I'm going to use a different color here. When I jump down to the second piece, I'll use for illustration, so all the students can understand what's going on here. They're saying, please, in that table, now try everything less than 0 for the x. By the way, since they gave 0 to me, I'm going to put 0 in my table since I see 0 staring at me. So we're going to see what's going to happen here. But they're saying, actually put in that table less than 0, negative numbers. And guys, you can try -2, -1. Other negative numbers you wish, you could use those numbers also. Let's put -1 first. -2, -3, -4, as many as you wish. That might be enough. Now, if I should use 0, which really says less than, not less than or equal to, but they listed 0 for me. If I should take 0 back here and put that in for x, that's a -0, which is 0. And there's my ordered pair for that one. -1, if I take -1 back, replace the x by -1, I get what? +1? That's my next ordered pair. -2 taken back will give me a 2. My next ordered pair. So I have ordered pairs to work with. Black, the orange. I'm supposed to go to a grid, plot points, connect them, and get a graph. But before I go to the grid to graph, any questions about what's going on here? You understand you have restrictions on the x. So on the side there, they tell you where the x's should be located, what types of x's are allowed to be used here in those tables. So guys, let's be patient, and I'll graph. I hope you guys can see this over here. I'm going to graph the black one first with your help. Here it goes. The table says for the black one, 0, 0. Plot 0, 0. That's the origin. It's right here. Now please tell me, should I have it open or should I close it in on the black graph? Yeah, we'll close it in because I see what there? An equals. So it's going to be equal to 0. So we'll close that in. The next point I'm looking at in that table looks like it's out 1, up 1. Go ahead and get ready for it. Out 2, up 2. So we plot those points. Out 1, up 1's here. Out 2, up 2's here. And I could add more points if I wish. And we'll connect them. What do you think on that one side there if I connect? What type of a shape am I going to get? Straight line. We'll get this for my graph. There we go. We got that. Goes on forever. That was your first piece done. Second piece in the orange, I did a table. It sort of help you. I did throw in 0 because they mentioned 0. But was there an equals mark on 0 in my second piece? No. So it says in that second piece, really, I got 0, 0, but I'm not supposed to do what? Not supposed to use it, really, right? Okay, so I should have an open circle there, but I've already closed it in, so I'm not going to reopen it. So we'll just leave it where it is. The next point is -1, up 1. Okay, before I put my numbers in. Okay, -1, up 1, guys, in the orange looks like this. And the other one's -2, up 2 looks like this. Plus, you got to keep in mind, it's going to connect down here. If I make them connect, and let's draw that orange piece, will I get, hang on just a second, there you go, a piece that looks like that? Is that the way the second piece looks? True? You guys accept that? I use tables. My goodness. I think I've seen that graph before. Oh, what's that graph? That was the absolute value of x. Are you kidding? Professor, erase your tables. Right down the graph. Are you telling me that all that Jesus did is this? Yes, I am. That's the absolute value of x. That's my V-shaped graph that we've seen before in here. But they gave it to you in pieces. And the pieces connected for me. Okay? I think the other one had maybe 3 pieces. Is that true, guys? Now, if I give one piecewise function on that test tomorrow, I just have time to do one piecewise function. I better do one with 3 pieces. I want to see one with 3 pieces. Okay, I see the one, I get 2 pieces here. Now, on the handout, and then read something here I gotta do with you, part B. On the handout, since I have it in front of me here, everyone do this. You know what? Hang on. I see the one. Yeah, why not? Okay, g of x. We'll change it to another piecewise function. But this one looks okay. The first piece, guys, is the first piece what? 4? 4. If x is less than -2. I'll do that in black when I finally get to the grid. Second piece is x squared if, and it looks like this one is written as, this. And the third piece is this. If I have it all copied down correctly here. Do I have all of them copied down correctly? The pieces? Now, if you want to construct tables like I did on my last one, get an idea what's going on, here we go, and we'll close down with these piecewise functions. Guys, let's go to the one black here. If, oh my goodness, I visualize a table representing this. They're saying, please try numbers less than -2 in your x column. Well, since they gave -2 to me, I'm going to start with it. But everything else must be less than -2. Like what, guys? -3, -4, so forth and so on. Now what am I going to do with them? Let's go back here and replace x by them. Is there an x there? So what am I going to place here for these values? Constant, 4. All the way down. You can add more points if you wish. And I'll come back to that table to graph the black piece. Now the orange, x squared, you know that's going to be a piece of a parabola. Here we go. Now here it says try these numbers. -2 to 2. I've got -2 given to me, and also you're allowed to try anything in between. Now how much you want to try is up to you. I'm going to throw in 0 and a +2. It may take more. I'm going to try those. If I replace x by -2 here, squared, that's a 4. I have another ordered pair. Put a 0 in there, 0 squared is 0. Another ordered pair. 2 squared, 4, another ordered pair. I'll use those to graph the orange piece. The green piece, this one. To construct a table to visualize this on the green, I'm going to start out with 2, even though they said try anything greater than 2. I'm going to try 3, 4, you can try more if you wish. X values must be greater than 2. Be patient, let's put a 2 back here, negative x plus 6, replace x by 2, I think you end up with a 4. Put a 3 in, do not make a mistake, I think it's 3. Put a 4 in, I think it's a 2. You guys agree? Let's do this quickly. Okay, at least I got the tables now. Now, I now need to see what the graph looks like. Let's put those pieces together. We'll see what this might look like if you put it over here. Okay, here goes. The one in black. Gotta be careful. Plot these points. These are like ordered pairs. First one says out -2, up 4. Okay. Get ready for it. And be very patient here on the last one. Here we go. I got the black piece, the table says -2 up 4. By the way, I'm gonna start with -2 up 4. Am I allowed to use it or should it be closed in, open? What happens with -2 up 4? Here, up to here. It's open. I don't see an equals mark here. At -2. The others though can be included. -3 up 4, -4 up 4. Let's get those on the other end. Let's look something like this. Let's see if you guys will agree. Got a point here. -4 up 4, got a point here. All from the table, yes or no? Is that enough to connect to see what the first piece looks like? If I connect, looks like it's lining up. Is it gonna look like this if I connect? Stay with me. And if I do it. Can you guys see that? The horizontal piece up there? Can you see it? Okay. Markers are right up on here. Now the orange. Orange, my table's here. First point says -2 up 4. Guys, -2 up 4 was open from the first piece. That's -2 up 4 from the first piece open. Now -2 up 4, I see an equals mark. What does that mean I can do? Include it. That means now I get to color the sin. Where are we? Here. And I get to do this. Other points in that table for the orange, 0, 0 is a point. Right here. And out 2 up 4. By the way, out 2 up 4, may I include it also? Can I darken it in or should it be open? Is there an equals mark there? Yes. So that means I can close this in and have it now to look like that. Is that enough to connect to get a piece of the graph I'm looking for the orange? From left to right, let's do something like this. And were you expecting a parabola on the second piece? X squared? Well, of course you would. Now, the last one says, hold on, green. Oh boy, I don't want to mess this up. I did this with the green. And by the way, this table's up to you as to what numbers you want to use. I got out 2, up 4. Seems like that is coming out again. Okay, out 2, up 4 is up there. The green, I don't see an equals mark, but have I closed it in from the previous? So I can't reopen it. It's got to stay like it is. So right here, if you want to put green, it's got to be there because I cannot reopen that that was closed earlier. Other points, I have out 3, up 3. Let's see what's going to happen. Scan this. And I think eventually I went out to 4. I did. Okay, out 3, out 4, up 2. So it's right in here. Guys, what do you think that green is finally gonna give me? What do you think when I start connecting? Is that green gonna be a piece of a what? Straight line. Mine may not be lined up the way they should, but it looks like it's gonna be a piece of a straight line. There's your piecewise function. There's your graph of that piecewise function. Wow. Now you're exactly, wow. I'm not gonna go crazy on you. I got an exam tomorrow. I do have a good exam tomorrow. Ooh, do I have a good exam tomorrow. And the review's been sent out to you. Mr. Barkley sent the answers out. I hope he sent out the correction also.
Okay.
Okay, so he's gonna send out, he said he made one mistake. Get you ready for this. Guys, you'll say, Professor, how much are we gonna do on that test tomorrow? With this new material, Professor, we just saw this today, Professor. Some of us have never seen this before, and all of a sudden we might have something like this on a test. Guys, if I give you a difference quotient, which I will, I gotta keep it basic. I'm not gonna go crazy on you. Maybe a quadratic. You saw a quadratic worked out earlier. Okay, I'm gonna give that to you and ask you to do that. Piecewise functions, I'd love to give you one like this. Oh, I'd love to. Would you guys see one like this? You think you could do it? With the help of the tables, could you actually take one broken up in pieces and put them back together and get a graph? Okay, so I was thinking about maybe not on this particular test placing a piecewise function, because you have enough to worry about. But you may have to do it on the quiz next Wednesday. Rather than on the exam tomorrow, you have enough to worry about. Okay, I'm gonna run out of time here, guys. So make sure you look at the difference quotient. What else did we do today? Oh, when you have a graph, you gotta tell me where it's increasing, decreasing, local max, local min. I think you guys all that really nicely today. One of those where a graph is given to you, you got to name the intervals, and so forth and so on. We did that today. We did different quotients today. Maybe quadratic. What else did we do today? We did so much. What else did we do today? Difference quotient, a graph. Did we get local max, local min? That would be like a graph supplied to you, and that's the name of local max and local min. So forth and so on. Okay? Now I'm not quite finished.
Any inequalities?
Now, those students who are missing class, if you miss class, I'm one of those professors, I will drop you. Especially if you don't send me. No consideration about sending me a message to say, Professor, I'm out. I understand for some reason, some things can happen in life. And I understand if you send, and some students, things can happen. And they'll say, Professor, I had to miss class. You gotta let me know. If you don't let me know, I don't know what happened to you. So all of a sudden, you come back into class and you check the roster, you've been dropped. Why would you enroll in a class if you don't need to attend? And some students do that. They will enroll, and I get rid of them fast. They enroll in a class and do not attend. And all of a sudden they come to me crying later on, oh, I've lost my financial aid, I've lost this, I've lost that, I've lost my status. What can I do? You weren't sure of you haven't showed up in class. You maybe showed up for the exams, but you weren't with me. Professor, can you can you put me back in? No, I'm done. How on earth would you enroll in a class and not attend? When another student who wanted to enter the class could not. Remember that first day how crowded we were? There were some students who didn't email me later on, they wanted to come in.